Ben Traynor-Sloss, the engineer who created site reliability engineering at Google, defined the role as what happens when you ask a software engineer to design an operations team. It represents a relocation of responsibility. The same shift is happening today. An agent designer is the result of asking a software engineer to design autonomy with boundaries. Migrating from deterministic nodes to code-first agents represents a structural rewrite of the job description, moving the focus from workflow execution toward the design of autonomy. Technical realities on the ground have moved significantly faster than the job titles used by the labor market. Misunderstanding this transition leads to optimizing for the wrong skills. It encourages treating a dynamic reasoning engine as if it were a predictable, static workflow script. This raises the central question of the series. Is the transition from automation engineer to agent designer a paradigm shift, or just industry hype? The answer lies in where systemic complexity lives and what a practitioner is paid to maintain. This diagram illustrates 3 distinct eras of orchestration. In Era 1, the unit of maintenance is the explicit deterministic path. The engineer is responsible for surgically editing branches within a sprawling node graph. In Era 2, the focus shifts to the capability spec. The practitioner maintains the tool contracts and the procedural knowledge packaged for the reasoning model. We then reach the era of governed autonomy. The unit of maintenance expands to the entire control surface, observability, evaluation matrices, and permission gates surrounding the model. This architecture diagram maps a technical ladder, scaling from simple path design toward total system governance. This stack demonstrates an email triage problem solved via Era 1 methods, using hard-coded branches for spam, sales, and support. Solving this in Era 3 requires a governed feedback loop. The model handles routing, constrained by traces, evaluations, and memory policies. Technical documentation from the field confirms this shift in responsibility. Anthropic's skills documentation defines the Era 2 shift. Instead of building topology, engineers package procedural knowledge into organized folders of instructions, scripts, and resources. Phoenix's observability documentation defines the Era 3 requirement. Because the system's inputs are unbounded, engineers must capture every tool execution, token usage, and latency spike to maintain control. Applying Era 1 maintenance habits to this architecture causes silent failures. Probabilistic routing requires constant measurement rather than manual path adjustments. While the LLM acts as the engine, a production-ready system must provide the chassis, the brakes, and the instrumentation. To understand why, we have to look at the 5 mandatory layers of the production stack. At the base is the runtime layer. Out-of-the-box loops fail without managing multi-window context and tool execution. Above sits the evaluation layer. Successful teams prioritize measurable online and offline success criteria over tweaking prompts. The observability layer follows. Agent monitoring must account for an unbounded input space. The stack is completed by memory and security layers. The prompt itself is a tiny component, dwarfed by the infrastructure managing it safely. This 5-layer harness provides the necessary guardrails to enforce stopping conditions on the underlying model's autonomy. Adjacent technical fields have already experienced this transition from manual task execution to system design. Historical technical case studies show a clear pattern of how these roles evolve. Web development evolved from hand-coding tangled HTML toward front-end engineers designing decoupled presentation systems. Data engineering followed the same path. Maxime Beauchemin recalled joining Facebook writing isolated scripts, leaving as an engineer architecting full-scale pipelines. Senior practitioners navigate these transitions by migrating their locus of control upward. They shift from doing the work to governing the system that produces it. Granting reasoning models cross-system privileges introduces severe and immediate security risks that industry hype often overlooks. Industry critiques and failure data highlight the specific risks of these agentic systems. Simon Willison notes that prompt injection remains an unsolved problem. Similarly, Meredith Whitaker argues that the magic genie bot concept fails once it collides with the reality of high-cost cloud processing and privacy needs. Gartner predicts that over 40% of agentic AI projects will be canceled by 2027, citing inadequate risk controls and high costs. The Replit incident involving Jason Lemkin provides a documented example of this risk, where an agent ignored a deterministic code freeze and deleted production data. These failures demonstrate that mixing autonomy with automation without Era 3 boundaries creates an unbounded blast radius. Era 1 workflows and Era 2 capability specs remain foundational maturity stages and are often the most appropriate starting points for a project. However, Era 3 governance becomes a mandatory requirement as soon as a system is authorized to impact production data. The agent designer's day-to-day work involves deciding what should be model-driven and what must remain deterministic. This role dictates what the system remembers, how success is measured, and when it must halt to ask for human intervention. As the technical complexity of these systems increases, proficiency will be measured by the ability to orchestrate the interplay of evidence, memory, and boundaries. Drop a comment with the era you are currently operating in and the one you are aiming for next. The transition from N8N to Claude Code shifts the focus from explicit path design to the precise delegation of reasoning. Mastering this orchestration defines the next era of automation, regardless of